All right, all right, all right. Welcome everyone. Week 2 of the Chainlink Hackathon. Really excited today to have Connor of the Ava Labs team talk us a little bit about the Avalanche blockchain and how to go about building your first dApp on Avalanche. If you have questions throughout this workshop, make sure to drop them into the chat. The way this one's going to be structured, Connor has a presentation kind of going on an intro into Avalanche, some of the benefits of using it in your hackathon project for the first half. And so if you have just generalized questions about Avalanche, we can stop there and answer any of your questions. And then we'll go into a demo about how to actually use Avalanche. And so then we'll be able to answer questions at the end there as well. Without further ado, Connor, thanks a lot for joining us, and I'll let you take it away.
Hey, yeah, thank you so much. I'm really excited to be here today with you all, teach a new generation of folks how to build on Avalanche, and it's an incredibly exciting protocol. It's a really great place to be, and yeah, I'm really excited to have you here. So yeah, today, I'm going to talk to you a little bit about Avalanche, but the real focus is on getting you guys to build your first dApp and your first smart contracts on Avalanche. So first of all, I'm an employee of Ava Labs. So who is that? So we are the company who is the custodians of the Avalanche blockchain right now. So we develop the core protocol. We also help other companies and other individuals build on top of our platform. And we also do a little bit of application development of our own and are launching our own applications. So who am I specifically? So yeah, I'm Connor Daly. I'm a software engineer at Ava Labs. And my primary responsibilities are actually doing dApp development, writing smart contracts, doing some front-end work to create some real applications, and also helping other people and other teams integrate with us and do their own development. So yeah, my claim to fame so far at Ava Labs has been that I created the Pangolin Dex, which is a application, one of the first applications on Avalanche that's been getting a lot of traffic recently. And yeah, so as you can see, I used to get haircuts, but this headshot of me is starting to get a little bit out of date. But new pandemic, new me. So here's what we're going to talk about. So we're going to start just going a little quick overview, very short, of just kind of like, what is Avalanche? Why is it cool? Why should you be building on it? Then talk about how to build Avalanche, what it means when you come over from building on an Ethereum-like ecosystem, what the differences are, what tools you can use. And then we're going to get into a demo and talk about how to actually go about building on Avalanche. So there's really, I think, two things that really set Avalanche apart from everybody else out there in the ecosystem. And the first is Avalanche consensus. So we have a revolutionary new consensus algorithm that I'm not going to dive too deep into here, because personally, I'm not the best expert at the company, but there's some really great deep dives videos out there on YouTube if you're interested. But basically, Avalanche consensus is a total departure from both classical consensus for things like Paxos that you might have heard about, and Nakamoto consensus that powers things like Bitcoin and Ethereum. And the way it kind of works is it actually does a bit of like random sampling. It's like you ask a bunch of people which transaction they want to accept, and then if you eventually can, if you ask enough people and do enough random sampling, you can come up with an answer. And it turns out that this is a very efficient approach, and it can be coupled with any civil defense mechanism. So you could use it with proof of work. We use it with proof of stake. And this approach really lets us kind of take a best of both worlds approach. And kind of the end result, the punchline of all this, is that we have a system that is incredibly fast and is incredibly high throughput. We're able to achieve finality in a matter of a couple seconds, and we're able to support thousands of transactions per second without really sacrificing any decentralization. And in fact, the protocol does not slow down with the more users it has. So it's really efficient. It's much greener than proof of work as well. It doesn't have anywhere near the performance constraints that Bitcoin does or even Ethereum does. And it's a totally new breakthrough, and it's really, really cool. The next thing that really differentiates us is that we are a network of networks, or a blockchain of blockchains. So what this means is you can actually kind of create your own blockchain on Avalanche. In the old world, that Bitcoin and Ethereum, there's one set of Bitcoin miners, or there's one set of Ethereum miners, and they're all validating the exact same blockchain. But with Avalanche, we kind of shake things up a bit. we actually created a system where there's multiple blockchains, and you can create your own blockchain, and you can have different validators who validate different chains. And so there's kind of two pieces of this. There's the creating your own blockchain part, your own virtual machine, as it's called. The virtual machine is basically what determines what's a legal transaction and what actually, how those transactions get executed. So an example of this would be like the Ethereum virtual machine on Ethereum. The Ethereum virtual machine defines a standard of smart contracts and defines a method of sharing state between a bunch of different parties, and talks about how to execute functions so that you can have smart contract logic to manage transactions. Another type of virtual machine would be like the Bitcoin script languages that defines Bitcoin, for like pay to script hash or pay to pub key hash, those functions and the code that executes them. So you can have these different types of virtual machines on Avalanche. So we've currently ported over the Ethereum virtual machine, but we're actually working on new virtual machines that can do additional features. And we're hoping that other people will build on top of us and add their own blockchains and their own virtual machines. And the other part of having your own blockchain is having your own validator set. And basically, the validator set is you're choosing who can participate in consensus. So you can just say it could be everybody in the world, or it could be some kind of subset. So what's interesting about this is you can actually accommodate some really interesting use cases. Is normally you kind of have to choose between being a permissioned blockchain or a permissionless blockchain. And this is kind of allows us to create a spectrum where we can blend both types. So for instance, like if the US government wanted to launch a subnet on Avalanche, they might want to trade United States assets, but they only want validators to be US citizens. This is actually a use case that we could accommodate. Or just more simply, if you wanted to create a subnet just for you and your friends, you could whitelist all the participants directly and really have a small validator network. So this allows you to create your own custom blockchain that runs on Avalanche. And the cool thing is you don't have to worry about your consensus algorithm. You don't have to worry about chain-to-chain networking. That's all handled for you in the background. And you just have to actually focus on the parts that could make your subnet or your blockchain unique. So like I said, there's multiple chains on Avalanche. So which ones are there already? What exists? So there's three primary first-class chains on Avalanche right now. The X chain, which is our exchange chain, the P chain, the platform chain, and the C chain, our contract chain. So our X chain is all about making payments. It's all about creating all kinds of assets and trading them really, really quickly. In fact, the X chain doesn't actually use a blockchain. It actually uses a DAG, but it's incredibly fast. Then there's also the platform chain. The platform chain is a chain that's basically made to manage the state of the entire Avalanche ecosystem. It's used to coordinate staking. So you can stake and unstake your tokens, and you can also use it to create your own blockchains, which are called subnets. And then lastly, we have the C chain, which is the contract chain. So this is where we're going to be living for the rest of this presentation. So the contract chain is a smart contract framework. It is a fork of the Ethereum virtual machine and executes Solidity smart contracts. And so this is where you're actually going to have the most bang for your buck developing smart contract applications. So it is the best place to build. It is, like I said, it's compatible with all your Solidity smart contracts. It's compatible with all your existing Ethereum tools, and it is blazingly fast. Once you use the C chain, going back to Ethereum, it just feels like you're like playing the lottery every time you do a transaction, because it's just like transactions are always mined. They're mined within a few seconds, and it's just so fast and so consistent. All right, so now how do we actually build on Avalanche? So I mentioned this contract chain. It's a fork from the Ethereum virtual machine. Are they identical? What are the differences? So I'm going to assume you know some Solidity here, kind of going forward for the rest of the presentation. This isn't so much an intro to Solidity. It's more of an intro to how to take your Solidity and Ethereum knowledge and bring it over to Avalanche. If you have no experience with that whatsoever, there's some really great resources on the Solidity documentation about how to get started. But when it comes to actually building applications on Avalanche, we're entirely feature complete with the EVM. Everything the EVM does, we can do too. So really all of the differences that you are going to see are going to be about assumptions rather than about functionality. So the single most important thing that you have to realize when building an Avalanche application is that the block timing is different from Ethereum. So in Ethereum, blocks are issued at a fixed rate. They come out at about like 1 every 15 seconds. And so what a lot of people do is they will use the block number as a proxy for time. So if there's a block every 15 seconds, if you want your application to wait a minute before it does something, you'll check that the block number has increased by 4. But if you do that in Avalanche, we issue blocks as needed. There's no fixed time interval between blocks. So that means that 4 blocks might come out in a span of 2 seconds. So you can't use that same timing. And if you're adapting an existing Ethereum application, that's something you have to be aware of. And the fix for this is simple. Just don't use the block.number. If you're ever thinking about using time, you have to use the block timestamp. The block timestamp is guaranteed to be within 30 seconds of wall clock time. So another difference is just our infrastructure progress. We're a new chain. Our mainnet launch was in September, I think, of last year. So we're still very new, and we're still bringing over a lot of the key DeFi and smart contract building blocks. So one thing that we don't have yet, we don't have an Ethereum name service implementation. Our Chainlink Oracle integration is currently ongoing and should be complete very soon, but it's not quite there yet. But if you're building a product on Avalanche and you're like, this thing isn't here yet, and I want to bring it over myself, please do, and please let us know, because we're happy to promote your work and give you credit for doing that. Because there's just so many things to bring over. We're working as fast as we can to bring over as much as we can. And so that's kind of our backward-looking kind of feature compatibility. But what's it going to look like in the future? Because we're not content at just taking the work that Ethereum did and just repackaging it. We're interested in pushing the space forward and bringing you new features. And so the first of which is actually going to be coming in our Apricot release, which is going to be our first really major post-launch release that adds a lot of features to the Avalanche ecosystem. That'll be coming in the near future. But the biggest change that's coming with Apricot for the C chain is that we're incorporating cross-chain assets. So what this is going to mean is that you're going to be able to take assets that originate on other blockchains, in particular the X chain, and bring them over to the C chain to work to use in your smart contracts. And so for any of you who are like super technically minded and know the intricacies of the EVM, we do have a few different precompiled contracts that differ from what Ethereum has. But if you don't know what that means, don't worry about it. All right, so now let's talk about the tools that you can use to build on Avalanche. So there's kind of 2 sections here. There's Avalanche native tools that we have built, and there's also a bunch of Ethereum tools which we've worked to help bring over to the Avalanche ecosystem and developed config files for you so that you can integrate as easily as possible. So the first one is our web wallet. So this is just a single one-stop shop where you can look at your balances across all of our chains. You can send assets back and forth. You can stake and unstake your AVAX tokens. You can also view any ERC20s you've been sent or view any NFTs that you have. It's pretty cool. We implemented a whole NFT studio to help people mint their NFTs and transfer them. We also have our own testnet. It's called the Fuji testnet, and we have a faucet that is live for that. So if you want to get started building on Avalanche, you don't have any mainnet tokens, you can just go to this faucet and receive tokens on the X chain or the C chain. And if you want to run your own copy of this faucet, you can run it on localhost. So Ganache is a really popular Ethereum local network simulator. So we created a similar one called Avalanche, which basically will actually set up a multi-node local Avalanche network on your computer with a bunch of pre-funded addresses. So you can simulate having a full network on your computer. And we have some scripts to automate that for you. Our Geth equivalent is known as Avalanche Go. So it's a full node implementation written in Golang. It has all of the JSON RPC calls that you'd expect for Ethereum, plus a bunch of other ones to accommodate our different chains. And it builds for all major operating systems, and you can also look at the source, build it from source. We also offer a hosted service where you can use our API nodes to interact with Avalanche Go, but there's also companies that are doing Infura-like services to host Avalanche Go nodes. One of them is known as Figment, if you're interested in getting a hosted service. And we also have Avalanche JS, which is a library similar to Web3 that basically just provides JavaScript, TypeScript bindings for all of the standard functionality for the Avalanche chain on all the X chain and the C chain and the P chain. And then we also provide a Postman collection. So if you're interested in doing these JSON RPC calls just directly, you don't have to mess with any messy curl commands. You can just kind of do it in a nice, repeatable GUI format. And we've created this collection so that it has all of our JSON RPC calls ready for you, so you can just start using it right away. All right, so that was a lot. Those are all the tools we developed. Most of them are not super interesting, but now we're getting into the Ethereum apps that we've brought over from Ethereum that most of you may already be familiar with, that we've configured to run on Avalanche, so they're just ready to go right away for you. First is MetaMask. Everybody knows MetaMask. It's the most popular web wallet right now. What's cool about MetaMask is it's actually multi-chain, and it's very easy to configure for different networks, and they're really starting to pivot and lean into this brand identity of being kind of a passport for all of these different Ethereum-based blockchains. And you can actually reuse the same addresses and the same private keys that you have across multiple different chains, which is just super, super cool. And so we've developed an Avalanche config that is available right here at this link. And also will be, they actually made a change really recently, so that now there's a new command you can use from your front end. So if you develop an Avalanche application and a user comes in and they're currently on the Ethereum network, you can send them the Avalanche config directly from the application itself, so that users won't have to implement this for you. Truffle Suite. So this is something that is hugely popular in the Ethereum space for deployment and testing. It's a really popular developer framework. We've created a config so it works for Avalanche, and you can just go through and set it up, and it should work just as it does for Ethereum. You can use Ganache as well. So Hardhat's a newer Ethereum deployment and testing framework, very similar to Truffle. This is actually my personal favorite tool out of everything here, and I'm going to talk a lot more about it towards the end. But the configuration for Hardhat is in our Avalanche Smart Contract Quick Start repo, which is a collection of tools that I put together to help get you going as fast as possible. And I'll show you that at the very end. So Wrap2Vox. So if you've done any development on Ethereum before and have worked with ERC20 tokens, you've probably come across WETH, or wrapped ETH. And basically what this is if you're dealing with the ERC20 token standard, if you haven't heard of it, it's basically a standardized interface that lets you know how to interact with tokens. It lets you view their balances of any address. It lets you transfer tokens from one person to the other. It lets you approve other people to spend on your behalf. And it just defines that so you can have one standard interface to talk to any kind of token. Well, that interface was developed after the Ethereum, the Ethereum mainnet launch. And so native ETH doesn't actually implement the same ERC20 standard. So if you want to work with financial assets, you end up kind of having to do two code paths, one for ETH or Avax natively versus your ERC20 standard for all of your tokens. And it's really a pain in the butt. And so some folks, I think who worked at Gnosis and a few other companies came together and they created this wrapped ETH contract. And basically what it does is it converts your native asset into an ERC20. So you can just write one code path that treats the native asset of ETH or AVAX as a wrapped ERC20 token. So we've ported WETH over to Avalanche. We have wrapped AVAX. It's the same contract basically, and we have a official deployment on both mainnet and on Fuji. And so this repo makes it available for everyone to use. It's totally permissionless. So now for explorers, we actually have at least 3 explorers on Avalanche. The Avalabs team deployed our own native Block Scout explorer. There's another company who's running one called Avascan and another one called vScout. And I gotta say, they're all really incredible. They're all really impressive. They all do a couple things slightly differently, but they provide a ton of really awesome data. And I sometimes will just like leave a window open and just like watch all the transactions fly by. It's really fun. Yeah, I would check out all of them and see which one you like best. One interesting thing about them is because Avalanche does have these multiple blockchains. Each explorer provides a different view for each chain. So you can see all the different transactions on the X chain. You can see all the different transactions on the P chain, the C chain. It's not just one unified stream. It's actually several. And now we're starting to get to like the actual applications that have been built on top of Avalanche. And I'm not exaggerating when I say like these new applications are literally being launched every day. And if you like yield farming or trying out new dexes, it is just like a minefield right now. There's like at least one launching every week, and new chances to try to get airdrops, to try to be early on these dexes. It's really cool. So as I mentioned earlier, I was the creator of this Pangolin Dex that launched a little bit over a month ago. So we have a very Uniswap similar exchange that is up and running, and now there's a few others. There's like I know Yeti Swap. There's another one called like Elk Finance that launched this last week. There's a bunch. There's another one coming soon called Panda, I think. Literally coming up like every day. And then now there's some other applications that are being built on top of these dexes. So for instance, there's 2 that have come out recently. One's called Snowball, another called Beefy. Snowball is a clone of Pickle, I believe, from Pickle Finance. And I don't know what Beefy is exactly, but it's a similar, these are auto compounders that basically take your yield tokens and reinvest them in the platform. And we also have Ethereum bridges. So the Avalanche Ethereum bridge is a bridge that will let you take your Ethereum tokens like Link, like ETH, like USDT, and actually bridge them over to Avalanche so you can use them in Avalanche applications. And we've had literally hundreds of millions of dollars worth of assets bridged over. And they're all trading on Pangolin and these other dexes. And it's really awesome to see. So if you're worried about like tax implications of selling all your tokens and like buying them on another chain, you can just bridge them right over and not have to sell them. Or if there's anything that just hasn't been implemented on Avalanche, you can just bridge it over and it's there for you, and it's really cool. And so you might be thinking, well, we got to the end of this and Connor didn't talk about my favorite Ethereum tool. Well, great news. It's really easy to bring over almost any Ethereum tool you want. There's really just kind of 2 steps that you have to do and then maybe a little bit of fine tuning. But in general, you just have to change the Ethereum client URL. So instead of using Geth or Infura or Alchemy or something like that, you have to point it at an Avalanche Go node or an API node from a service like the Avalabs hosted API or Figment. And then you also have to change the chain ID parameter to 43114. So chain ID is basically the unifying parameter that determines like which chain you're on for Ethereum similar chains. Ethereum is number 1, and then every other chain has a different unique value. So for our testnet, it's 43113. For our mainnet, it's 43114. And I mean, usually that's about it. Sometimes you might have to do other things. For MetaMask, you also have to supply a Explorer link, but sometimes it's a little bit of fine tuning, but it's really simple. So if your favorite tool is not listed here, give it a shot. Try bringing it over. It's probably not that difficult. And if you're having trouble, just send us some messages on Twitter or on Discord, and we can try to help you out. All right, so now we're going to transition a little bit. Now we're going to talk about actually building on Avalanche through this smart contract quick start repo that I put together. So this is my favorite way to write smart contracts. And this was just my thinking of, I've got a workflow. It works for me. It's really easy. I fine-tuned it as best I can. How can I bring this workflow to other people and make it as fast and easy for them to start developing as possible? And basically, the simple answer is it's hard hat pre-configured for Avalanche. So as I mentioned earlier, hard hat is a development environment for deploying and testing smart contracts. It's kind of similar to Truffle. And the reason I love it so much is because it is the best debugging environment that I've found for Solidity. And if you've written any Solidity before, you know that debugging sucks. It's very difficult to tell when something goes wrong, like what happened, why it happened. And Hard Hat does an incredible job at making that simpler. And basically the way they do that is they have a local EVM instance, kind of similar to Ganache, but hidden more behind the scenes. And they have a bunch of deployment scripts that allow you to go directly to this Hard Hat network. And they are able to give you stack traces when any of your contracts revert. They tell you what line that your contract reverts on, and it gives you the whole call trace. And then it also allows you to provide print statements in your smart contracts that will log to the console, regardless of whether or not the transaction reverts, which is just like, oh my God. It's so useful. And they also provide some really incredible testing suites. So you can write unit tests and you can do mock calls. And it's just, if you've done like enterprise software development before, you actually can do many of the things that we've had to throw away for so long. You can actually like implement all these best practices and stuff, and it's really awesome. And they also just have really great easy script integration. So if you want to write a script that can call your contracts and interact with them, you can easily do that through Ethers.js and Web3, and it's significantly easier than just using any of those libraries on their own. And lastly, it supports multiple networks. There's basically just a -- network flag, and then you put in the name of the network you want to use, and then you can use the same calls regardless of where you want to deploy. So how does this get fine-tuned for Avalanche? Well, basically, we have a Hard Hat network configuration, and we fine-tuned it so that it's already pointing at the Hard Hat network. It's already points at our local testing network, Avalanche. It's already pointing at our Fuji testnet, and it's already pointing at our mainnet. And like I mentioned, there's this -- network flag option, and you just type in, where do you want to deploy? Do you want to deploy to mainnet? Do you want to deploy to Fuji? Do you want to deploy to Hard Hat? And it just will take you there. We've also provided a bunch of custom scripts and stuff to help you do some Avalanche things like fund addresses, send to Vox, whatever you need to get started. So the next piece of the smart contract quick start is OpenZeppelin. So if you've done any development in the Ethereum space before, you've probably come across OpenZeppelin. They are the gold standard for reusable, reliable smart contracts. They have tons of different implementations for things like tokens, data structures, like the enumerable set is one I use, math for doing like safe math that reverts on overflows, proxies for upgrading, tons of stuff. I use their contracts in probably every project that I work on. And so we've gone ahead and we've imported the OpenZeppelin package into the Avalanche Quick Start repo. And we've created a little demo contract so that you can create an ERC20. And you can launch this in literally like just a minute or two. And, all you need to do is go in, you can change the name, the symbol, and like the decimals, so you can customize your token. So it basically is what you want it to be, and you can launch it almost instantly. And that's what we're going to be doing in our actual demo. So if you want to use this smart contract quick start repo, what do? Well, basically, you can just clone it, you can jump in, swap out our demo smart contracts with your smart contracts, start writing. Then you can write some unit tests and then deploy. And like, that's really it. You may want to change some of the, you might want to change the Git repository that it's in, so it's not in the fork. You might want to move it into a different repository, but that's all simple Git stuff. All right, so now we can get into the demo, but I said, we can take some questions now at this point if we'd like to.
Cool. Yeah, thanks, Connor. Yeah, let's see if we have some questions. If you have them in the YouTube, feel free to drop them in the chat here. Doesn't look like there's too many questions. Probably will be some more as we dig a little deeper into the code. One question, what are some projects that you really see a need for on the Avalanche ecosystem as like the first ones that you're looking for? Especially coming from you, obviously, Pangolian was a big, the Dex situation. So that fascinating being able to launch that. What else do you see as like kind of like those big first things that you need to have like a successful blockchain?
So yeah, what's really hot right now is DeFi.
Yeah.
That's where the utility is in Ethereum. That's where all the money is going right now. Now we're also seeing that in NFTs, but I think DeFi is like the first crucial infrastructure for having a successful project and really getting money on your platform.
Mm-hmm.
So that was really the thinking behind launching Pangolin, is that swaps and dexes are super crucial building blocks for other infrastructure as well. And so that was why we chose Pangolin as our first project. But going forward, like, what are the things that we need? I think lending is something that's hugely important, and just all the other DeFi building blocks. So now we're starting to see compounders show up on dexes. I would say the dex market is getting pretty saturated on Pangolin at the moment. So if you're interested in building a dex, try to do something a little bit different, because I think we're getting a lot of kind of very similar dexes coming out that it's harder to stand out. So I would say, bring over a lot of the other financial building blocks that exist on Ethereum and on other chains right now that we don't have on Avalanche. That's a huge thing for us. And all these other DeFi products, because they all work together so well, and they're these building blocks that you can create more and more applications on. So I would say DeFi applications, things that can build on DeFi applications. But the other big thing right now is NFTs. Yeah. And I think there's huge opportunities there. We don't really have an NFT marketplace or something right now. So if people are interested in innovating, we do have a couple projects that are starting to create some NFT generating projects. Somebody ported CryptoPunks recently over to Avalanche, so we now have AvoxPunks, and yeah, so I would love a CryptoKitty on on Avalanche. But I think, and also just some of the infrastructure there, things that can help creators. I think those would be really cool. But we're still so early. Yeah. So if you have ideas, or even if you don't have ideas, you just see really cool projects on Ethereum. That, I guess the other thing I didn't mention about Avalanche is our fees are dirt cheap. Our fees got really expensive because we hard coded the fee value, and our token price went up significantly. So we went from being a few cents to a few dollars. But don't worry, we're going to get that back down in our Apricot release. But we hate being so expensive, but just like it's if you have applications on Ethereum that it's just not worth it to spend hundreds of dollars on to do the most basic functionality, and you're like, I wish I could do that on Avalanche. Though I wish I could do that cheaply. Those are the products that we want to bring to Avalanche.
Cool, love it. Yeah, I always think it's good to get the why and like what can I do, and then let's dive into how to do it. So yeah, take us away.
All right, so I'm gonna just show you. So this is the link for our quick start repo. So I can try to send out these slides if I can. I'll talk to you again later. Or if not, just search Avalanche Smart Contract Quick Start, or it's on the Avalabs GitHub page. You'll find it.
Yeah, we'll drop you the Avalanche Discord after this.
Okay, great, perfect. All right, so first I'll just navigate to here, and I'll kind of like walk you through what's going on. All right, so this is what the repo looks like. So first of all, we've got a pretty extensive README here. So we're just going to try to walk you through. We have a lot of steps, a lot of pictures, just to walk you through everything you can do here. The only step that I'm really not going to show you myself that you would need to do is you need to install Yarn, which is very easy, or install NPM as well. Those are just very basic Node packages, which I'm sure you guys can handle that. But yeah, basically, when it comes to doing this, we talk about how to actually do an installation. Basically, all you do to install your dependencies is just type yarn, hit enter, and then you're good to go. And then Hardhat has a bunch of commands. We've also created vanity scripts in our packages.json, so you can just do things like yarn compile, yarn deploy, and just do everything super quickly. So we've got a bunch of functionality here. We also have a bunch of like custom tasks to show you the accounts that you can currently write from, what the balance is for all of those accounts, how to set up, how to use our custom scripts, how to get help, how to set up a local Avalanche network, a bunch of really cool stuff, how to work with MetaMask. So I'll just talk about the code layout real quick. Obviously, I'm not sure if you can actually see this, so I'll zoom in a little bit. So there's a few folders. So one, there's the contracts folder. So this is where you would actually put your source code. There's the image folder. This is purely just for our README. You could delete this folder later. Scripts, we'll have our custom scripts that you can use to deploy and interact with all of your contracts. Then we use test for all of our unit tests. We have standard git ignore. We have a license, so we're providing this under the BSD-3, the three clause license. It's a very permissive license. The only thing you're not allowed to do is claim that we endorse your project without asking us. But you are totally free to swap out that license with whatever you want. So no worries there. We're not restricting you in any way. You're not required to release under the same license. And then we have a couple different config files. So to get started, let's just clone this repo. So I've just got a terminal here. Now I'm just going to clone this. So I'll now cd into my directory, and let's start up VS Code. Okay. So I'll show you. We've set up a few different contracts here for you. So we've set up coin.sol, which is exactly what I mentioned earlier. This is just a contract that you can use to mint your own ERC20, and that's what we're going to do in just a couple minutes. So you can mint your own ERC20. We also have this ERC721.sol. If you're like, what the heck is ERC721? This is an NFT. So if you're interested in implementing your own NFT, this is a very fast way to do it. We also have this really crazy piece of code here called mock contract. This is not written by us. We stole this from the Gnosis team. It is a contract that allows you to do mock calls. So if you've ever done any like enterprise unit testing with mocked calls, you can do them with your smart contracts, which are just hugely, hugely useful for people coming over from that kind of environment. And it allows you to test individual smart contracts without relying on having the source code for every other smart contract known to man, and without having to necessarily set up the state in those contracts. You can set up the state manually rather than kind of having to go through all the steps to do it the long way. Then we have a bunch of scripts here. We have a deploy script. That this is all using the Ethers.js library under the hood. You could also use it with Web3 if you'd like. But yeah, basically we just have the ability to quickly deploy. If you change your contracts up, you do need to make some changes to the deployment script. We have some examples for how to write other scripts. We wrote some crazy functions to help you fund your C-chain addresses to facilitate testing. We wrote some scripts to just send a box. And then we also have this test folder here. So this is where you can actually do unit tests. So it looks very much like any kind of enterprise unit testing library you've probably used before. You can do, before you start your test suite, before each individual method call, then individual unit tests, and it'll display really nicely for you. And we'll do some unit tests later. And then this is kind of where the moneymaker is for us right now, as far as like what makes this repo special is we've kind of done this configuration for you, and there's this hard hat config file. So here you can define some custom tasks, which will do things like show you all the accounts you have, all the balances you have in those accounts. Here's where you can hard code the versions of Solidity that you're interested in using. One really cool thing about Hard Hat is you can use multiple Solidity versions in your project. So I used to run into this problem with Truffle where I'd have some code that was at like version 0.516, another version that was at 0.76, and the compiler could only do one version. It couldn't do both. So this will actually use different compile versions for different files in your source directory, which is just, if you're using code from a couple different sources, is just hugely, hugely useful. And so now here we've done all the configs for you for the different networks. So we have the hard hat config, we have Avalanche for a local network, and we're providing a bunch of preloading all the private keys for Avalanche that are pre-funded with Avox. So you have like 1 million in Avox in each account, so you don't have to worry about setting that up. So the only thing that you need to do if you want to actually deploy to Fuji or mainnet is come in here and just drop the private key that you want to use in this configuration file. We're trying to do an update where we create an env file so that you don't actually have to put your private keys in this file, and you don't actually risk accidentally uploading them to GitHub. But that's the only thing you need to do to actually start deploying on mainnet or Fuji. So now I want to jump back to our ERC20 and actually deploy one. So I'll kind of just do like a deep dive on what's going on here. So like I said earlier, we're going to be stealing from OpenZeppelin. We're going to be using their ERC20 contract. So we've already added this as a dependency. All we need to do is look at the actual code here for what we're going to be deploying. So I'll show you. So this is OpenZeppelin's ERC20 documentation website. So they have a ton of really great contracts here. Like I said, I use their stuff literally in every project I use. So they have an ERC20 interface if you're just interacting with an ERC20. We're going to be using their core ERC20 library, but they also have different extensions for different types of ERC20s. Like you can have a capped asset, so you can't mint more than a certain amount. You can make yours pausable so that an owner can stop the contract from circulating if there ever a problem. Things like that. We're just going to use the standard one for right now, but if you come to this documentation website, it tells you about all of the functions. All the functions you can use, what events they emit, how to call them. Just really nice documentation. They also have a GitHub site where you can view the actual Solidity source code. And so these are all their contracts. So these are all their folders of contracts. So they have crazy amounts of good stuff. So if you come over to token, ERC20, ERC20.sol. So this is what we're actually importing. This is what we're actually using. So you can see we have constructors, fields for all the different things, all the methods. This is the real contract that we're going to be interacting with. One thing I want to say about OpenZeppelin, I noticed when I was putting together this presentation that they have released a new version since we put out this quick start repo, and the new contract version uses the 0.8.0 contract versions and are no longer backwards compatible with the 7 series of Solidity versions. So I need to go back and bump that version up for OpenZeppelin. But for this presentation, we're using the 0.7.0 library, and that's totally fine. It's still backward. It still works today if you download it. Okay. So what are we actually doing in this code here? So like I said, we're just importing our token interface from OpenZeppelin. We're specifying a token name. Right now, we just have my ERC20 token. That's really lame. So I'm going to call this Connor coin instead. We need to provide a token symbol. So let's go with CC. Then we can provide token decimals and total supply. I'm fine with that. So we'll have 2 tokens. Then we'll mint 1 million of them. And so I'm just going to mint them to myself. So that's all this contract does. It's really simple. I'm going to save it. And then I'll show you, we'll come over to our deploy script. So what does the deploy script do? So basically, all we do is we get a copy of the contract ABI. Then we just call deploy on it. And then we just wait for it to be deployed. And then after we're done, we're just going to print out the address that we just deployed to. So now let's come back over to our terminal, and we will actually do some of this. So first thing we do is we have to install our dependencies. So I'm just going to type yarn, and away we go. So now we're installing Hardhat, we're installing OpenZeppelin, and all of the other libraries that go along with it. This just takes a few seconds. Bam, we're done. We're ready to go. So now this is what Hardhat looks like. So I just did yarn Hardhat help. So basically you can just do yarn Hardhat, and then any Hardhat command that follows will be added to it. And then we have some vanity commands. So like if you just do yarn compile, that will match to yarn Hardhat compile, stuff like that. You can check that out in the package.json. So here, there's a bunch of config options you can do, but there's also a bunch of tasks. So like I mentioned before, you can display all of the accounts that you're using, yarn Hardhat accounts. And you can run any of these tasks like this, and it'll show you these are all the addresses that have been preloaded into Hardhat. So you can look at the accounts you have. You can look at the balances of all these accounts. You can clean. You can compile. You can open up a Hardhat console. This is a super useful one. You can do a flatten. So if you ever verify your source code on one of our explorers, it's a very similar process to Etherscan, but you have to flatten your code. So if you're importing code from different modules, you actually have to condense it into one file. You have to load in your imports and put them in a single file. So that's what flatten does. So flatten will just do that for you. I use that all the time. And then help, and then you can just like run your unit tests. You can also run generic scripts. So like I said, I ran this Hardhat's accounts command a moment ago, and this showed a bunch of accounts. So the cool thing about Hardhat is you can just pass in this -- network flag, and it'll run the command against whatever network you passed in. So if we look at the Fuji testnet, you'll see we have no accounts loaded because we haven't actually provided any private keys for those accounts yet. So then we can also, if you don't provide any network, it's going to run on the Hardhat network. So then we can check the balances. And we'll see each of these accounts is preloaded with a significant amount of AVAX. So next, here's what we can do. We can do yarn deploy. And this is actually going to deploy our token onto the Hardhat network. So at first it compiled all the code real quick, and it deployed our token onto the Hardhat network. with this address. Bam, we're done. And it'll actually deploy it deterministically on the hard hat network. So it should come up with the same address if you don't change anything, which is useful for testing. But deploying on hard hat is one thing. I mean, you guys probably want to see this on like mainnet or Fuji. So I have gone ahead and I've pre-funded an account, and I can come over here. I'm going to go to my hard hat config and add a real account to Fuji. There's a real private key, so if you guys want to, you can go try to steal my 2 Fuji testnet AVOX that I put on there. Don't worry, I don't use it for anything else. All right, so now we put in our new address, so we should be able to look at this. So if we look at accounts on Fuji again, we should now see one account. And it's there. We can check balances. Good, and we've got a few AVOX there. And it's like, I think that's 1.9 when you account for all the decimals. So now let's just go ahead and deploy our token. So this is actually, it's connected to our Avalanche API node. So it's going out, hitting those, doing a real deployment, waiting for the deployment to be confirmed. And bam, there we go. So this is our token address. So now let's come back over. I minted 1 million tokens to myself. So if I come over to MetaMask, which I have set up for this account, I can come over here. I've configured MetaMask to point to the Fuji testnet. So I added a custom network. I'll show you what that looks like. Networks. So this is what our Fuji network config for Avalanche looks like. You can find this on our documentation website. It's pretty prominent, but it's very quick to set up. So I'm pointing at Fuji right now. So I can go to add a token, custom token. I'm going to copy and paste in that contract address that I just did. It grabbed the symbol for me. It grabbed the number of decimals. So I said, do that. And I'm going to add the token. It can tell that I have 1 million of these CC tokens already. So I'm going to add them to my wallet. And bam, now it's there. And I can use my tokens in MetaMask and send them to whoever I want. So that's pretty cool. So I could grab one of these like hard hat addresses and send them there, whatever. So that's really great. The last thing I want to show you guys is just how to do some unit testing really quickly. So I'll just open up our unit test really quick. So as I mentioned before, so basically what we have it set up to do right now is just before the module gets invoked, just grab a copy of the ABI and also deploy a copy of the mock contract, or sorry, get a copy of the mock contracts API. And then before each method invocation, before each test, redeploy a new copy of the contract. These are all going to be executed on the hard hat network, so it's free to test. And then you can just write simple unit tests, like expect your deployed contract. You call the decimals function on it to equal decimals. We could write another test to check, the symbol of our deployed tokens. We'll just check the symbol. So we'll call the symbol method. To equal CC for my Connor coin. And then here's another test I'll just show you real quick. So this is just how you would set up your mock contract to do a mock. You just basically specify, this is a function call name. So if the balance of address is ever called, given that method, return this integer amount, which amount is like 150. So now we can just come over here and do yarn test. Everything's already compiled, and it'll just run through your test suite, and bam, everything passes. And if we change it, it was Connor Daily Coin. If we ran this again, we should get a test failure. So yeah, didn't get the test we wanted. So yeah, that's about it. That's about all I have. Just the last thing I was going to close with is just tell you guys, like where do you want to go next? So if you're interested in, once you've deployed your token, how can you actually use it? Well, you can interact with it directly. If you want to use, you can use Hardhat scripts for this. So I would recommend checking out Hardhat and the Ethers.js library. You can do that at Hardhat's website. If you're interested in building a dApp with a front end and a website, you can go, there's two things I can recommend. So there's Web3 React, which is written by the Uniswap folks. That's super useful. We use that in Penguin. And then there's also the Truffle Suite component Drizzle, which I've never used, but should work as well. So yeah, so that's all I have. So yeah, thank you so much. Happy to take any questions for any time we have left.
Cool. Yeah. So yeah, really appreciate you taking the time, Connor. It looks like we have a few questions. Do you have the slides for this publicly available somewhere?
Not yet, but yeah, I can share them in the Discord. Is that what you said earlier?
Yeah. So I already dropped the GitHub link, but yeah, if you could just drop those into the Avalanche channel, I think that'd be super helpful for everyone so they can go back and review those. So we'll drop those there. Otherwise, yeah, if you guys have questions for Connor, anything about Avalanche, some of their team members are in there, definitely just hop into our Discord and be able to answer any of those questions there. Otherwise, Connor, yeah, really appreciate you taking the time. This is really fascinating and really thank you.
Yeah, thank you so much for having me. This was really fun.
Cool. Well, anyone else that's listening in, make sure to hop into the Discord and we'll see you next time.
All right, thank you.